Good day, everyone. We are the Group 7, and our topic is all about inheritance and polymorphism.
Good day, everyone. I'm going to tackle about inheritance. So, what is inheritance? Inheritance is one of the fundamental concepts of object-oriented programming, and it allows a new class called subclass or child class to acquire the properties and methods of an existing class called superclass or parent class. And also, this concept helps programmers to use existing code instead of rewriting it, making programmers easier to manage and extend. Next is the subclass and superclass. Superclass provides common attributes and behaviors that can be shared by other classes, while the subclass, on the other hand, extends the superclass by adding new features or modifying existing ones. For example, we have a person class that contains basic information such as name or age. Subclasses like customer or employee can inherit those features and add their own, such as purchase info for customers or employee ID for employees. And also, this creates a clear and logical relationship between classes. And it also promotes code reusability because we can write shared features once in the superclass and use them across many subclasses. Using the super keyword, when a subclass inherits from a superclass, it can call the instructor or methods of the superclass using the super keyword. This ensures that the inherited part of the class is properly initialized before the subclass adds its own data. For example, a class person, we have the string name, the person, and the parameter, which is the string name. And then for the class employee, we have the two parameters, the string name and ID. So in this example, employee inherits from person. The keyword super with the name class now constructed a person to access the name, while the subclass add a new attribute which is the ID for employee, the specific details. Through inheritance, programmers can build hierarchical relationship between classes, organize code effectively, and also make programmers easier to maintain and expand in the future. That's all for the topic of inheritance.
Good morning, everyone. So we're going to present what is polymorphism and application in QI framework. So, what is polymorphism? So, polymorphism is means many-form. So, it allows the objects of the different subclasses to be treated as objects of a common superclass. So, while behaving a different based on their specific type, there are one, two, three, four. So there are four specific type of. So the method overriding. So what is method overriding? So method overriding, subclasses replace as inherited method with their own implementation. So the second is shape interface. Shape interface is different classes use to the same methods name but execute a unique logic. So shape methods interface has a unique logic has a unique execution by doing this. So the third is code adaptability. So it makes a program to be flexible because methods can act differently depending on the object type. So, last is the dynamic invocation. So, the program decide to runtime which version of a method to execute depending on the object and the actual class.
In this slide, we have an example of polymorphism using the SaveDetails method. Polymorphism simply means that a single method name can perform different behaviors depending on the objects that using it. First, we have person class, which is the superclass. It defines a general method called SaveDetails. You can think of it like a basic function that saves a person details to a default database. Next, we have the employee class, which inherits from the person class. Since it doesn't make change to the SaveDetails method, it just uses the same default version from the person class. Finally, we have the customer class, which also inherits from person, but this time, it overrides the SaveDetails. That means it changed the behavior of the method. Instead of saving the default database, it saves to a different customer database. So even though all these classes have the same method name, each one can perform different tasks. That's the main idea of polymorphism. One method, many behaviors. Now let's move on to the next slide, the power of dynamic resolution. This slide shows how polymorphism works in action. Here we have a base reference. Person P equals new customer. This means we are treating a customer object as a person type. Then we call the method. Because of dynamic resolution or runtime polymorphism, Java knows that P actually refers to a customer object, not just a regular person. So when this line runs, it will automatically execute the SaveDetails method from the customer class, not from person. In other words, even if the reference type is person, the actual method that runs depends on the object real type, which is customer.
Application in UI framework. So in this part, it shows that UI frameworks customize the component by first is extending a base class. For example, creating a custom button by extending GButton. So the second one is overriding methods. So overriding methods, changing how methods like point or action perform work to give a component a unique look or behavior. So the third is adding complex behavior. So allowing the developers to build advanced, reusable components easily. So the second part gives the GUI example called the shape calculator. So the class shape has a general methods such as computer area and compute parameters. The second is subclasses like circle, triangles, rectangles overrides these methods to calculate area and parameter differently based on their specific properties such as radius, length, width, or base and height.
GUI example shape calculator. This report discusses the concept of inheritance and polymorphism in objective-oriented programming or OOP. Using a graphical user interface GUI example called shape calculator. So first we have base class shape. The shape class serves as the parent or superclass for all the shape types, it defines two methods that are common to all shape. First, we have computer area. Then the second one is computer perimeter. So these methods are later overridden by its subclasses to provide their specific implementations. So the second one is subclasses. The shape class has three subclasses. So first we have circle, which overrides the methods using the radius. Then the second one is rectangle. It overrides the methods using length and width. And the third one is the triangle, which overrides the methods using base and height. Each subclass defines its own formulas for computing area and perimeter, showing how method override works in OOP. So the next slide is polymorphism in action. The following Java code demonstrates the polymorphism. So in this example, the variable is declared as type shape, but is assigned an instance of circle when S computer area is called. Java dynamically determines the actual object is a circle, so it executes the circle class's computer area method. This behavior illustrates runtime polymorphism. So for another slide, key takeaways inheritance code structures. Inheritance builds extensive hierarchies consisting of superclasses and subclasses. So the second one is method derivation. Subclasses derive methods and properties from parents class, allowing for code reuse. So the third one is focus. The main goal of inheritance is code sharing and organization, reducing redundancy. So the next is the key takeaways polymorphism. So first we have adaptability. Subclasses implement inherited methods in their own unique ways. So the second is dynamic resolution. It enables method calls to be resolved dynamic at runtime based in the object types. So the third one is impact. Polymorphism allows developers to create flexible and maintainable code that is easier to modify and extend. That's it.
Good day everyone. In this video, I'll be explaining our shape calculator program. This program lets the user choose a shape like circle, rectangle, or triangle, and then calculate its area and parameters based on the values they enter. So let's begin. First, we import the scanner class, then the arrays. Next, we define our class called shape calculator. We set up the scanner to get input from the user. Then we display a message on the screen using this line. Select shape, circle, rectangle, triangle. This message tells the user to choose which shape they want to calculate. After that, we use this line, string shape, to store the user's answer. So whatever the user types, like a circle or triangle, will be saved in the variable shape and used later by the program. Then try. Try is used to handle possible input errors so the program won't crash if the user enters something invalid. If the user chooses circle, the program first asks for the radius. That's this line. The value the user enters is stored in a variable called radius. Then we calculate the area using the formula. Area equals pi times radius times radius. Next, we calculate the perimeter. Using the formula, perimeters equals 2 times pi times radius. Finally, the program displays the result using this. So the user will see both the area and perimeter of the circle printed on the screen. Then if the user chooses rectangle, the program asks for two values, the length and the weight of the rectangle. Next, the program calculates the area using the formula. Area equals length times width. Then it calculates the perimeter using the formula 2 times the sum of length and width. If ever the user chooses triangle, the program asks for the three sides, side 1, side 2, and side 3, and store them in variables A, B, and C. Then the program adds all three sides together to get the perimeter. Next, we find the semi-perimeter, which is half of the total perimeter, using this line. Now, we use Heron's formula to find the area of the triangle. The formula is area equals the square root of S times S minus A times S minus B times S minus C. Finally, the program prints the area and perimeter so the user can see the result. If the user types something other than circle, rectangle, or triangle, the program says valid shape. Let's try to run our code. Let's try to select rectangle. The length 3.14, then the width is 4.5. So the area is 14.13 and the perimeter is 15.2. Let's try to run it again. Let's choose circle. The radius is 0.1. The result is area 110.0. The perimeter is 30.3. Let's try another shape. Triangle. The sides 1, 2.1, 3.7, then the side 3 is 4. The result is area 3.8, then the perimeter is 9.8. That's all, and thank you for listening.